Welcome back to RoboFication for AI Safety Critical Systems. I'm Mike, your systems engineering expert with extensive experience in industrial applications. Today, we're diving into a cornerstone of AI systems engineering: simulation. In the world of autonomous systems, testing in the real world can be both expensive and risky. So, how do we ensure these systems are safe before deploying them on the road or in the sky?
And I'm Sophia. I specialize in AI and robotics research, focusing on developing intelligent systems that can adapt and learn. When it comes to AI and robotics, simulation isn't just an option, it's essential. From self-driving cars to drones, simulation is how we test and refine AI models without putting lives or assets at risk. Let's dive into how it works and why it's so crucial.
So, why is simulation such a big deal for autonomous systems? Well, think about it. Testing a self-driving car on real roads is fraught with uncertainties. There could be unpredictable weather, pedestrians behaving erratically, or complex traffic patterns. A malfunction in these scenarios could be catastrophic. Simulation allows us to recreate these high-stakes environments safely.
Exactly. And that's where AI simulation shines. Simulation environments enable us to test autonomous systems in countless scenarios without endangering anyone. We can recreate extreme weather conditions like heavy rain or snowstorms and simulate rare but critical events such as a pedestrian suddenly darting across the street or unexpected obstacles appearing on the road.
That's right. It's like pushing these systems to their limits in a risk-free, controlled environment. For example, in the aerospace industry, we use simulation to test how autonomous drones handle harsh conditions like turbulence or extreme temperatures without risking any actual drones. This not only ensures safety but also accelerates the development process by identifying potential issues early on.
So, Mike, how exactly does an AI simulation work for autonomous systems? What's happening behind the scenes?
Good question, Sophia. At its core, simulation creates a digital twin of the real-world environment. It's essentially a virtual replica of the physical world, complete with dynamic elements, like pedestrians, vehicles, and obstacles, that interact with the autonomous system in real time. This digital twin allows us to observe how the AI makes decisions in various scenarios.
Yeah, and it's not just about static environments. Advanced simulations incorporate sensor emulation, replicating the data that real-world cameras, LiDAR, and radar would feed to the AI. It's almost like a highly sophisticated video game where the AI is the player, making decisions based on what it sees through its virtual sensors.
And for experts like us, it goes even deeper. These simulations are built on high-fidelity physics models and multi-agent interactions, ensuring that the behavior of every simulated entity mirrors real-world dynamics. For instance, the way a virtual pedestrian walks or how a simulated car maneuvers can be finely tuned to match real-life behaviors, providing a realistic testing ground for the AI system.
Simulation has really revolutionized AI systems engineering, especially in safety-critical industries. We can now test how self-driving cars navigate urban environments without putting anyone at risk. It's incredible how much safer and more reliable these systems have become thanks to simulation.
And it's not just about safety, it's also about cost efficiency. Real-world testing is incredibly expensive. Imagine crashing a test car repeatedly or flying drones into hazardous environments to gather data. With simulations, we can run thousands of tests in parallel, which is both faster and more affordable. This scalability allows us to iterate quickly and improve the system continuously.
And let's not forget edge cases, those rare, unpredictable events that often cause real-world failures. Simulations let us test these unusual scenarios, like a pedestrian suddenly crossing in front of the vehicle or a drone encountering unexpected wind gusts. These edge cases are crucial for ensuring the AI can handle any situation safely.
Exactly. And in industries like healthcare, where autonomous systems are used in robotic surgery, simulations allow us to test precision and reliability under controlled conditions before performing on real patients. This ensures that every move the robotic system makes is safe and accurate.
Of course, no technology is without its challenges. One of the biggest hurdles in AI simulation is achieving high fidelity, the degree to which the simulation accurately replicates the real world.
Right? A high-fidelity simulation needs to capture real-world physics, environmental changes, and even human behaviors accurately. If the simulation isn't realistic enough, the system might perform well in the virtual world but fail in the real one. Balancing realism with computational efficiency is a constant challenge.
And there's the computational cost. Running thousands of high-fidelity simulations requires immense computational power. While cloud-based solutions are helping, it's still a balancing act between achieving high realism and managing processing time and costs.
Another significant challenge is generalization. Even if a system works perfectly in a simulation, the real world is inherently messy. There are so many unexpected variables that are hard to predict or replicate in a virtual environment. Ensuring that the system can generalize its learning from the simulation to the real world is crucial for its success.
The future of AI simulation is pretty exciting, though. One of the most promising developments is the use of AI-driven simulators, where the simulation itself evolves based on real-world data. This could allow simulations to mirror real-life conditions even more closely, making them more effective as testing grounds.
Absolutely. And there's also the concept of sim-to-real transfer, where models trained in a simulation are fine-tuned in the real world. This bridges the gap between virtual testing and real-world performance, ensuring that the AI system retains its reliability when deployed.
And let's not forget the potential for continuous learning. After deployment, real-world data can be fed back into the simulation, allowing the AI to keep improving and adapting long after it's been deployed. This creates a feedback loop that enhances the system's robustness and adaptability over time.
To sum up, AI simulation is a game-changer for testing autonomous systems safely and efficiently. It's how we ensure these systems can handle the unpredictable world before they ever hit the streets or skies.
And while there are challenges like simulation fidelity and computational requirements, the benefits, like cost efficiency, safety, and scalability, are undeniable. AI simulation is the key to pushing the boundaries of autonomous system development.
In our next episode, we'll be diving into safety-critical standards for AI, how industry standards like ISO 26262 shape the development and certification of these systems. Stay tuned for that.
Don't forget to subscribe us YouTube at RoboFication, follow us on LinkedIn and X at RoboFication, and share your thoughts below. We'd love to hear from you.
Thanks for joining us on RoboFication for AI safety-critical systems. Let's keep building the future together.